Okay, for this question here, showing that EDB, so let's draw EDB, that angle there, is going to be the same as EBD, which is going to be this angle here. Now, EBD is actually going to be easy to figure out initially, because we know that that is going to end up being theta. Actually, we'll give it a little, we'll denote it as such. We'll call EBC alpha. This in the middle we'll call alpha. So I'll write that down. EBC equals alpha, and therefore EBD is going to be alpha plus theta. Now, just to add to more information, this one up here is also going to be alpha because of alternate segment theorem, and therefore we know that angle EDB, this one up here, is actually going to be equal to the sum of these two angles. So that one there is going to be alpha, so angle DB is going to be equal to alpha plus theta. And I'll show an example of that. So if we had theta and we had alpha, this angle over here would end up being 180 minus alpha minus theta, and therefore this one here is going to be the inverse of that of sorts. It's going to be 180. Take this 180, take 180, cancel each other out. The minus makes a positive, minus makes a positive. It ends up just being your alpha plus your theta. And that's exactly what's happened in our situation. Now, because we end up getting EDB equals alpha plus theta, which we call the sum of interior angles, that therefore means that EBD and EDB are the same. Now for this next question, this is just figuring out that to go from to go from the length of BE, there's a ratio that compares that to a line that goes, a chord that goes all the way through from one point of a circle to another. And that is this formula here. Let's just move this out of the way. BE squared equals EC times EA. Now, because BE we don't know, aside from knowing that's the same as DE, and that is what it says in the question, does it? It should. Of course, it's because it's an isosceles triangle, because we figured out that it's got the same angle around point B and around point D. So we can say that BE equals DE equals X. So I'm going to say BE equals DE equals X. And therefore, you should be able to therefore see that EC is going to be x take 6, because we know that CD is 6. So EC therefore equals 6, or equals x take 6, and EA would be x plus 11, because remember that ED is the same as BD, and then we're adding the AD part of 11. So EA equals x plus 11. Now that we've got all that, we can just do the maths, and then from here it's pretty straightforward. I'll just pause and write it all out. And that's what we end up with, x equals 13.2 centimeters. So that's what we have to do there. There was a bit of a tricky rearranging, but hopefully as long as you're able to realize that BE and DE are the same, because having the same angle would mean that they're of the same length, because the isosceles triangle, which I should mark. Therefore, you know that it's gonna, you can then denote that as x. You can then end up using it to figuring out everything that you need to. Once you have that, once you have DE, you can end up really using it to figure out everything else. So that's what you would need to do for that one.